Hey students, are you ready to learn?
In three, two, one.
Welcome to my channel.
We are done with groups and abelian groups. Let's now proceed in alternating groups. In alternating groups, we have the three topic we are going to talk about. First is the transposition, next is the odd and even permutation, and lastly, we have the alternating groups itself. So let's talk about first the transposition. So transposition So transposition is a cycle of length of 2. So a transposition have a length of 2. So every cycle is a product of transposition. So let's have an example. So let's say we have 1, 2, 3, 4, 5, 6. And we have 5, 2, 3, 4, 1, 6. So let's find its transposition. So first, let's start with 1. 1, 5, 5, 1. Then bumalik agad. It returned into the original, which is 1. So we have 1 and 5. And its length is 2. So let's say for example, S sub 6. No, S sub 1. So we have S sub 1 is 1 and 5. Again, let's have an example. We have the S sub 2, which is 1, 2, 3, and 1, 3, 2. So we have 1, 1. We don't need to write the 1, 1 itself. We're going to write the 2, 3, 3, 2. So we have 2 and 3. Last example, let's have this. So we have 1, 2, 3, 4, 5, 6, and 7. Let's say we have 7, 2, 3, 6, 5, 1, 6. 6, yes. 4. So we have a length of 1, 7, 7, and 1. So we have 1, 7. That's how we're going to find a transposition. So now, in transposition, there are 3 remarks. First remark is that any cycle with at least two elements is a product of transposition. So in symbols, so let's have an example. A sub 1, A sub 2, A sub 3, dot, 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 A sub n. So in we're going to write its transposition like this. We have A sub 1 and A sub n, again A sub 1 and A sub n minus 1, then proceed to A sub 1, here, A sub 3, then A sub 1, then A sub 2. That is the first remark. The second remark is the identity. Permutations. So let's say we have 1, 2, 3, 1, 2, 3. The transposition of this is that 1, 2, 2, 1. That's it. So the last remark is that if A is equals to 1, we cannot form a product. So let's say, for example, 1, 1, 1, 1, 1. We cannot make a product out of this. Let's now proceed to even and odd permutation. A permutation of a finite set is even or odd, or it can be expressed whether a product of even number of transposition or a product of odd number of transpositions. Let's have an example. This. We have the 1, 2, 3, 4, 5, 6, 7, 2, 3, 5, 7, 1, 6, 4. Let's identify if it is even or odd permutation. So, let's start from 1. Let's list like this. So, 1, we have 1, 2, 2, 3, 3, 5, and from 5, we go back to 1. Next, we have, since it is already done with 1, 2, 3, 5, let's go for 4. So we have 4, 7, and going back to 4. So how many transposition are there? So we have 1, 2, 1, 3, 1, 5, 4, 7. So how many are there product of transpositions? We have 1, 2, 3, 4. 4 is an even number. So this number 1 is a even permutation. Let's see if the second one is even or odd. Let's list. So we have 1, 3. Let's go to 3. We have 5. 5. We have 4. 4. We have 2. And 2. We going back to 1. So we have that. So since we are already done with 1, 2, 3, 4, and 5, let's go to 6. Let's go to 6. So we have 6 and 7. So again, let us list transpositions. We have 1 and 2, 1 and 3, 1 and 5, 1 and 4, 6 and 7. So how many transposition are there? 1, 2, 3, 4, 5. There are 5. 5 is an odd number. Therefore, this is an odd permutation. Next, let's have an example. We have 1, 2, 3, 4, 5, 6, 7, 7, 6, 2, 4, 5, 3, 1. Let's list again. So let's start with 1. We have 1, 7. Let's go to 7 and we have 1. It's going back to 1. So let's stop there. So now let's proceed. Since it is already done with 1 and 7, let's proceed to 2. We have 2. What next? 6. Let's go to 6. We have 3. Let's go to 3. We have 2. Let's go to 2. We have 6. Therefore, it is going back to the number. So last, we have the 4, 4. We are not going to write the 4, 4 because we don't have a product of transposition with 1 like this 4, 4. So we're not going to write 4, 4. So we have 1, 7, 2. It's already go back to 2. So sorry for the mistake. So we have 2, 6, and 2, 3. So we have 3 product of transposition. Therefore, it is odd permutation. So let's see for number 4. We have 1, 2, 3, 4, 5, 6, 7, 2, 4, 5, 7, 6, 1, and 3. Let's list again. Let's start with 1. We have 1, 2. Let's go to 2, 4. Let's go to 4. We have 7. Let's go to 7. We have 3. Let's go to 3. We have 5. Let's go to 5. We have 6. And let's go to 6. We have 1. It goes back in 1. So we don't need to list it again. So let's now list the product of transposition. We have 1, 6, 1, 5, 1, 4, 1, 3, 1, 7, and 1, 2. So let's count. 1, 2, 3, 4, 5, 6. We have 6. Therefore, 6 is even. Therefore, it is even permutation. Last example, we have the identity, which is 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. We can list whatever we want, like we can choose 1, 2, or 2, 1, or we can choose 5, 6, or 6, 5, or we can choose 3, 4, or 4, 3. Therefore, an identity is an even permutation. Let's just always remember our 3 remarks. If we have 1, we do not have a product of transposition. And if it is an identity, we have 2 product of transposition. And whenever we have this, you can list and count the number that you had created. Then you can identify whether it is an even or an odd. That's all for odd and even permutation. We are already done with transposition, odd and even permutations. Let's now proceed to alternating groups. So in alternating groups, the subgroup S sub n, consisting the even permutation of n letters, is the alternating group of A sub n on letters. So we have a formula n factorial over 2. So let's have an example. So number 1, find the alternating groups. Find the alternating group of A sub 3 of S sub. Alternating group A sub 3 of S sub 3. So we just need to compute for this so that we can identify how many even permutations are there. So we have 3 factorial over 2 is equal to 3 times 2 times 1 over 2 is equal to, cancel na natin, let's cancel. So we have 3. So there are 3 even permutations out of A sub 3 of S sub 3. What are those even permutations? So those are, let's have to list. Those are the 1, 1, 2, 2, 3, 3. We have the identity. Next we have the 1, 2, 3, 3, 1, 2. And lastly, we have the 1, 2, 3, and 2, 3, 1. That's it. So let's have another example. Find A sub 4 of S sub 4. So again, let's compute. Let's just substitute the n factorial with 4 factorial over 2. We have 4 times 3 times 2 times 1 over 2. Cancel, cancel. 4 times 3, we have 12. So there are 12 even permutations. 12 even permutations. So we are just going to list those 12 permutations. First we have the identity. 1, 2, 3, 4. 1, 2, 3, 4. Next, we have here the 1, 2, 3, 4, 4, 1, 3, 2. Next, we have the 1, 2, 3, 4, 1, 4, 2, 3. Next, we have the 1, 2, 3, 4, 2, 4, 3, 1. Next, we have the 1, 2, 3, 4, 2, 1, 4, 3. Think again. We already have 1, 2, 3, 4, 5. We all need 7. So we have 1, 2, 3, 4, 4, 3, 2, 1. Next, we have 1, 2, 3, 4. 2, 3, 1, 4. And next, we have 1, 2, 3, 4. And 4, 2, 1, 3. We already have 1, 2, 3, 4, 5, 6, 7, 8. And we just going to find 4. 4. We already need 4. So we have 1, 2, 3, 4, 3, 2, 4, 1. 1, 2, 3, 4, 1, 4, 3, 2. And next we have 1, 2, 3, 4. We have 3, 4, 1, 2. Lastly, we have 1, 2, 3, 4, 3, 1, 2, 4. Let's check if all of it are even. First, the identity. It is already an even because we have the 1, 2 or 2, 1, 3, 4 or 4, 3. Next, we need to proceed 1, 4, 1, 4, 2, and bumalik again. So, we have 1, 4, 2 or 1, 4, 1, 2. Then it is even. Let's check if this is even. We don't need to write the 1, 1. So, we have 2, 4. Let's go 4, 3, and going back to 2. So, we have 2, 4, 3, and that is even. Next, let's go to 1, 2, 2, 4, 3, 3, 4, 1. So, we have 1, 2, 4, and we don't need to write the 3 because 3 is do not have a product of transposition. So we have 1, 2, 4 or 1, 2, 1, 4, and that is even. Next, we are here 1, 2, 2, 1, 3, 4, and 4, 3. So we have 1, 2, and 3, 4. That is even. Next, we have the 1, 4, and 2, 3. That is even again. So correct, 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 and correct. Let's see if it is correct. 1, 2, 1, 2, 3, and going back to 1. 1, 2, 3 or 1, 2, 1, 3, that is even. So next we have 1, 4, 4, 3, 3, 1, and going back to 1. 1, 4, 3 is even. 1, 4, 1, 3 is even. We have 2. Next, we have 1, 3, 1, 3, 4. We don't need to write the 2 already because we have 1, 3, 4. 1, 3, 4 is even again. 1, 3, 1, 4. Next, let's proceed to this. 1, 1, we do not need to write the 1, 1. We have the 2, 4, 2, 4, and 1, 3. That's it. Next, we have here the 1, 2, 3, 4, 3, 4, 1, 2, or we have the 1, 3, 2, 4, 4, 2. That is even again. So lastly, we have the 1, 2, 3, 4, 3, 1, 2, 4. We have the 1, 3, 1, 3, 2. We don't have to write the 4. So we have 1, 3, 1, 2, and that is even. So we already answered find the alternating group of A sub 4 of S sub 4. So we have the 12 even permutation, and we all list the 12 even permutation, and that's how we are going to find the alternating groups. That's all.